In this video clip, we're going to take a look at database design. One of the things you want to do before you design your database is identify the data that you want to put in the database, and then identify the relationships between the different groups of data. And there's a name for this process. It's called normalization. And normalization will go out to what's called, I think, 7th normal form. But in this video clip, we're going to take it to 3rd normal form. And it's a process where we can identify sort of our groups of data and the relationships between the data. And once we have that done, it's easier to create a database, and it makes it much more efficient when you try and do some programming against the database to bring data out of the database or to put data into the database. So imagine, if you will, we have a spreadsheet, and this is going to be our puppy database, where we have puppy names. The puppies belong to certain kennels, and of course we have a location for the kennel. And the puppies know how to do certain tricks, all right. And each trick has an ID, and in each trick, perhaps this is sort of an abbreviation. It says trick where learned. Where did they learn the trick? Maybe they learned it from a trainer, maybe they learned it at an academy. Who knows? But just wanted to have another field in the database. And then what skill level do they have for this trick? I mean, maybe 1 is the best and 3 is the worst, but what kind of skill do they have? So imagine a spreadsheet like this. And then imagine maybe hundreds of rows, right? This will be a row of data. Imagine hundreds of rows with all this in there, right? So what we want to do first, and that's what we have down here. If I scroll down here, you'll see that the first step into getting into 3rd normal form is to eliminate repeating groups. So if you can imagine, this is our unnormalized data, which is what I just showed you up here, unnormalized, right? So you have puppy number, puppy name, kennel code, kennel location, and trick ID. 1 to how many tricks can the puppy do? The puppy maybe could do 100 tricks, who knows? What's the trick name? Where was the trick learned? And what skill level? It could be a infinite number of skill levels, but who knows? So the idea here is we want to get this data into what's called 1st normal form. And the rule of thumb for 1st normal form, it says eliminate repeating groups. So how do you do that? Well, it says make a separate table for each set of related attributes and give each table a primary key. Excuse me. So what's an attribute? Well, an attribute basically just, if you think of it right now as a field that could be rated to another field that could make that group of data unique. Maybe that's a rough definition. Let's take a look at what we've done. So to get the 1st normal form, we've broken out puppy number, puppy name, kennel code. So all this right here into one table. It says for each set of related attributes. So you can see that puppies can be related to the kennel they're in. So they're related. So puppy number, this is all the kind of data or attributes are related to puppy number, right? Okay, puppy name, what kennel they're in, that sort of thing. And then the other one would be tricks, right? So each puppy can do a trick. So this is all related data. So it says make a separate table for each set of related attributes. So tricks are all related, right? And the skill that they have, and the puppies are all related, all right? And give each table a primary key. So what does that mean? So puppy number. So that would uniquely identify this row of data. So if I said puppy number 1, that would uniquely identify the puppy name, the kennel code, the kennel name, and the location. Okay, that would uniquely identify that. All right, because you'd only have one puppy there in that kennel. That would be named Scooby, for instance, Scooby-Doo. Then the trick table. So in this case, it says and give each table a primary key. So in order to uniquely identify each record of data in this table, we have to use 2 fields to make up the primary key, and this is known as a composite key. So it takes puppy number and trick ID to uniquely identify this row of data, to make it unique, because one puppy can do many tricks. So you can have that puppy number in there 3 times or 4 times, right? So, but that puppy number, like puppy number 5, can do trick number 1. That wouldn't repeat. You wouldn't have puppy number 5 doing trick number 1 and have that in there twice. All right, so that makes that unique. So that's how we get it into 1st normal form. So once we do that, then let's get into 2nd normal form. And I think you'll see once we go through this process that it sort of becomes maybe intuitive of how to do this without going through these steps. You can just kind of do it once you've done it for a while and make it and get into 3rd normal form very quickly. So here we go. So here's the next thing we want to do is eliminate redundant data. It says if an attribute depends on only part of a multi-valued key, remove it into a separate table. Well, remember the multi-valued key or the composite key was down here, right? This was our first normal form, and now we're trying to make it into second normal form. Say multi-value key or composite key. And so we're not quite done yet here, but we'll see. We'll move that in a second. We'll talk about that in a second. So what we did is we broke out a trick table, so we could just have trick ID and trick name. That way that you wouldn't duplicate that, right? It would be the data would not be redundant. You'd only have trick name one time in that table, right? As opposed to up here, you could see that trick name play dead appears many times in the spreadsheet, right? And it would appear many times here for each puppy, right? So now we've broken that out and made it such that it's in a separate table, right? And then we've given it a puppy number, trick ID. We have to relate those two. So this is still a composite key. So puppy number and trick ID still, are needed for this table here, all right, to make it unique. So we didn't do anything to the first table. It stayed the same. So then this third step would be, let's eliminate columns that are not dependent on the key. Okay, so what does that mean? Let's take a look. Get this situated right, if I can get this in here. So what we want to do then is, this is our second normal form, and now we've got it into our third normal form. So if attributes do not contribute to the description of the key, remove them into a separate table. So if you take a look at this, kennel code, kennel name, and kennel location really don't contribute to puppy name and puppy number. You might have some other information about the puppy, the age, the birth date, type of dog or type of puppy it is. That really doesn't contribute to this puppy, the information about the puppy. So we can separate that into a separate table. Right now we have kennel code, kennel name, and location. So that's sort of an entity of data, the kennel entity, if you will, just information about kennels. And then we just have information about puppies here. We could have more information than just puppy name, but we kept it brief. All right. And again, we have our keys, our primary keys that uniquely identify each row in that table as a different color here. All right. And we still have this down. So we didn't change this at all. This stayed the same. And of course, this is a composite key. So let's take a look at this and see how this relates. We have to now look at our relationships. So one kennel can have many puppies. So that would be a one-to-many relationship. Correct? So one kennel can have many puppies. Okay, let's take a look down here. One puppy can do many tricks. Okay, so now we can start to identify these types of relationships, and depending on the database you're using, whether it's be MySQL or Oracle or SQL Server or Access, so we're going to show, there's a diagramming tool that you can usually use to set up these relationships when you create your tables. So if you look at kennels, right, this is how we would do it: kennel name, kennel code. So a kennel can have one or more puppies, and we have to put the kennel code here to relate these two tables together. So having the kennel code in this table, in the puppy table, means that that's a foreign key. Okay, this is the primary key of the kennel table. This is the primary key. Puppy number is the primary key of the puppy table, and kennel code is a foreign key in the puppy table. And we can just drag in Access. All you have to do is hold your left mouse button down or click your left button down and drag kennel code to kennel code here, and it creates this relationship of a 1 and an infinite symbol, meaning it's a one-to-many relationship. And in Access, if you want to delete that or edit that relationship, you just right-click on the line, and it will do that for you. Now let's take a look at tricks. Right? One puppy could perform many tricks, so there's another one-to-many relationship. Right? And you'll notice this is sort of an intersection table here. Otherwise, it could be a many-to-many relationship. And usually that's bad when you're trying to design a relational database. You want to sort of eliminate your many-to-many relationships and break them down into one-to-many relationships. So if you didn't have this here, if you had information over here like we had before with the puppy information here, this would be a many-to-many relationship. It would be very difficult to program. So one puppy can do many tricks. And then let's take a look at this. One trick, right, or each trick can be performed by many puppies. And so that's how you have to start to think about how to organize your data like this. All right. Okay. So this is a quick overview of a process called normalization, which you could read more about on the internet if you want, on how to organize your data. And what we'll do next in another video clip is we'll actually build, well, we've sort of built it here with this diagram, but we'll show you how to build these tables and actually put the data in the tables using SQL, which stands for Structured Query Language. Each database vendor has their own variant of SQL. I think Microsoft has Transact SQL, Oracle has PL SQL, and Access has its own flavor too. There's several flavors, but they're also compliant with ANSI SQL It's just a little. They have their own flavors, I guess you could say, for each vendor tries to tweak it a little bit. So anyway, that's an overview, and we'll go from here.